Hello, Pietro.
Hi. How are you?
Oh, I know that you have your screen with me down below, so it looks like you're looking down.
Yeah, it looks like I'm looking at my feet. So yeah, no, I'm here.
Yeah. Okay. So I'm so glad that you're here, and I know that you've been busy working in Italy almost up until this point.
Yes, I had the opportunity to do an internship in Bologna, University of Bologna, 2 months.
Yeah.
And going back to my roots, going back to Italy, eat pasta and and all that stuff. Seeing Italy win in the European Championships, so all the good things. But now
Yeah.
I'm back since beginning of July. I'm back to Valencia and happy to be here.
Yeah, and you're a professor at the University of Valencia. So, and how did you end up in this course, may I ask?
You're talking about your course, or
Yeah.
Yeah, well, the Italian through an Italian friend. So I've been working with Marco Zennaro that already did a class, I think, a few weeks ago, 2 or 3 weeks ago. We have been working together with IoT, LoRaWAN networks, MQTT. I mean, communication topics related with IoT since I don't know, 5-6 years. And he proposed me this type of courses, and for me it's great. I mean, it's well, already the COVID helped a little to start this new way of teaching. I rather prefer, to be honest, I rather prefer to go to Sweden and teach the class in front of real people. But I mean, this is also an interesting way to teach, to try to explain something that I know on a topic that I like. I also do research on this topic, and I think it's a very interesting and I mean, it opens up a lot of possibilities, and so I think it's fun to try this new way to teach.
Yeah, and you're in your office now.
Now in my office. In my office, you can see all this. The background is a real background. So this is
and I must ask about that mask before we start.
When I have exams, I typically wear this for my students to fight with them. No. No, it's just a gift. We receive a lot of students from South America, and this is from students from Mexico.
Yeah, okay.
But I'll probably be using during exams or something like that. No, yes, here in Spain, the situation is, well, I mean, we can come to our offices, and labs are open, so we can have some real contact with people. So, but most of the work is done online. So
yeah.
Yes, I did. I could have put some slide with where Valencia is. So maybe not everyone knows where Valencia. Valencia is not as well known as.
Should you show like a Google Maps on where Valencia is?
So it's. Let's see, Valencia. Valencia is right on the east side of Spain. And here where the heart is. So here is Valencia. And I see Barcelona, which is more well known here, very close to Madrid, Barcelona, and it's a very nice city, very nice weather. Maybe not July, quite a little too warm. But starting September till May, June is very nice weather, a very nice place to live. Even for Italians.
That's great to hear. So, and we do have a topic today, and you have and you're going to talk about Docker for IoT.
Yeah. The idea. Well, so the idea is I'm not a, let's say, computer engineering person. I could define myself as a networking guy. I rather prefer networking, but you have, when you're working in general with computer science, you have to design applications, you have to use applications, you have to integrate applications. And what, you always have to, okay, well, I will install a virtual machine, or I will install a new operating system, then I will install these libraries, then I will install all this other software, and then I will be able to try this application. And this is fine, you can do it, but it typically takes time. If you do some modification and you want to let other users to use those modifications, those new applications, it takes time. You have to distribute all the software, you have to distribute all the instruction to say, okay, you have to compile this, and that, you have to install this library. So it becomes kind of a long and sometimes painful process. So I started using Docker because I found out that even without taking advantage of all the possibility that this technology offers, it actually simplifies the deployment and the use and the design of new applications. Even for IoT, even for, we don't have to think about Docker. Maybe someone think of Docker just for big data centers that they want to deploy very powerful application. Docker can be used even on, you will see a picture later on, even with the Raspberry Pi Zero, even with very simple devices. And it provides this. It provides an easier way to test new application, to deploy new application, to design new application, and distribute this application to others.
Yeah.
And so I thought this is interesting, useful. So that's why I proposed this short seminar on Docker.
Yeah, and also, I mean, when we're talking about Docker, we can't run Docker on a microcontroller, but almost like the Raspberry Pi you talk about.
You'll see later. We saw a picture that there is Docker can, for the moment, be deployed on Raspberry Pi Zero, which is, that's reasonably small device. I'm not saying, for example, Arduino, you will not use a Docker on an Arduino Uno. No. Or devices like, or the Nano 33, which is now the NanoSense, which nowadays is very used for example, TinyML application, that there will be a talk on this. But you can get reasonably low in the stack of an IoT deployment that makes this technology interesting for IoT. So that's why my interest in this type of tool, and that's why I propose to give. As you will see, the talk is very, it's an introduction. You will see, I prepared just a few slides to give, for those that never heard about Docker, what is Docker? So just to have an idea. And then my idea was to do, that's why I prepared here this other document, an hands-on session where we will actually play with Docker, with images, with containers, so that hopefully by the end of the seminar, people listening hopefully will have a more clear idea of what Docker are, how they can be used, and my idea is that we'll start thinking, okay, I have to design this application. What if I think it in a Docker way? So that's my idea. And so just I put this in this first slide, as you can see, a repository where all the slides I'll be using and the code that I'll be using, a link to the practical part document that I prepared is available, so that people listening to this seminar can do the same at home.
Yeah, and I've shared this link in the Discord live lecture questions channel, so you'll find it there as well.
Okay, perfect. Okay.
So I'll just if there are any questions during the lecture, I'm happy to monitor the Discord channel and let you know about the questions.
Okay. So so just let me know when I can start, and
yeah, sure, start.
okay. So welcome everyone. Here is, as I said, you can see the link to where I put all the material that I will use, and this is my name and where I work in Spain, Valencia, and my email address. If you have any question, you can reach me directly with this email. Okay, so this is basically something I already said. Is the idea is to see, or at least give an overview of how Docker works, what is Docker and how it works, and then we will, as I said, play a little with this tool. A good way, if you like this tool, a good place where to start is this one. Okay, and you'll have you'll have all the software to install it in your device, depending on the type of device. You will have access to the Docker app. I will show you what it is, and you can play with Docker, which means try to use Docker without installing anything in your machine. And later I also show this option. Okay, so an overview. What is Docker? So as I said before, what I was looking for was a solution to develop applications, use application in a easy way. I mean, in a simpler way than compile everything, install libraries, and look for dependencies and all that stuff. And as you see here, that is actually Docker. What offers is all this environment. It's typically called a DevOps solution. And so you can build your own application. You can build your own software. We can ship it and store it in a repository so that you can use it later, but others can access to those applications and use them. And you can deploy them. You can manage them, and you can scale them. I will briefly talk about this possibility. Maybe you heard about Kubernetes, Swarm, which are different way to use Docker. And so here you have another link, which in the web page of Docker, there are a lot of very useful tutorials. Actually, you will see later that I will reference some of them. There is really a lot of good documentation available. So a few terms, okay? When you hear talking about Docker and containers, you will also use here this difference in what is called monolithic applications with respect to microservices. And this is kind of an idea behind the use of Docker. So the idea is, okay, instead of creating a unique, huge application, this is an example application of kind of Uber application, where you have all the application integrated in a unique program. The idea is that, okay, split it into many different small applications, small services, microservices, and have them talk typically through a REST API, which is the advantage. The advantage is that you can focus, or someone of your team can focus on a specific part of your application. And this work can be done simultaneously by other members of the group, by other programmers, and all this application can integrate itself seamlessly. And this is thanks to a platform like, or a tool like Docker. Another idea that I wanted to clarify is which is the relation with Docker with respect to virtual machine, because you can say, okay, I will install a virtual machine in my device and I use it I do what I have to do in a virtual machine. Well,
one question, Pietro, before you skip into the virtual machine, is that I got a question about repositories. You said Docker repository versus GitHub repository. So Is this the same thing we're talking about?
We will see later. We will see. They are kind of similar. They are kind of similar, but they are not the same. We will use them. I will show them in a while, and then in the practical part, I will go to the repository, to the main repository of Docker containers, and we will see how it works.
Yeah, great.
In a certain sense, is similar. With GitHub, typically, what you distribute is the raw code, the source code. The Docker repository typically do not directly store the source code. You have to still put it in a, for example, GitHub repository. They store images, and I will show what images are.
Yeah.
Okay. See that what it says here: create and store images. Okay. Later I will show you what is. Okay, so the difference is what you see here. When we talk about virtual machine, imagine this is your host machine, your portable computer, your PC. When you install a virtual machine, you actually install the whole operating system, the libraries, and then you store the application. So this is very resources hungry, because you need a lot of memory, you need a lot of disk, you need a lot of CPU to handle 3, for example, like in this case, full operating system. So the idea is, let's make it leaner. Let's make it not that resource hungry, and let's have more application. Let's give the possibility to run more applications, and let's have just a very tiny amount of additional libraries and binaries to make everything work. So it's let's say Docker can be considered as a very let's say not resource hungry solution to have many different applications running on your system. So again, here's what I said before. You see here, this is an example with a Raspberry Zero. As you see, this can run, for example, it's a very air quality monitor. So there is the link here. You can check this repository, how it works. And this is, so you can run on your laptop or on your computer. It can run in virtual machine. If you want, Docker can run in a virtual machine, or it can run in a data center, Amazon data center, or in a mix of those types of environments. But for IoT, the interesting part is to have it running on devices like this or Raspberry Pis. And the advantage is that if your service it has to grow, the Docker itself provides you a way to make it grow dynamically in a very easy way. And so you can provide more service provider. Imagine that you are using a MQTT broker, or you are using a database, or you are providing, I don't know, a web page or a REST-based application. What if you have, instead of having tens of devices, you have hundreds of thousands? So Docker can scale your solution dynamically. And well, I will not have time to show it in this talk, but if you're interested in this and you check how to do it, you will see that it's very easy. I wanted to highlight this project, which is the Balina. Well, I pronounce it in Italian. I don't know if it's the right way to pronounce it, but it's Balina. It's a project that aims to run Docker on embedded devices, and it's working on putting Docker on very tiny devices. And for example, in this case, this example works with Balina. Okay, so there is a trend on using this technology for even smaller embedded services. So here you have the overall Docker architecture. Okay, so what you have to do when you install the Docker on your machine, what you install is basically what is called here Docker daemon. So it's a very tiny part of software, and what you will have to handle with this daemon are images, I will now detail what are images and containers. Basically, images are instructions on how to build a container, and container is the application you would like to run. Okay. So, for example, as you see here, you have just 2 images, but we have 4 containers. So from one image, we can execute as many containers as we want. And then we have the registry, which is the repository, that is where images are stored, the GitHub, the repository for Docker. And we'll see later. And we have a client that allows you to build, to pull images, to run images, to stop images. We will see that in the practical part. So the registry. So remember these 3 elements: registry, images, containers. So the registry is this repository. Or if you want we will go later. Okay. So here you will see that it's something like this. That is, this image was taken a few months ago. Now I think there are 8 million, more or less, available images, which means 8 million possible application about everything. Okay, so just imagine here, you can have the complete Java environment up to a very simple application that we will use in a few minutes. This is a public repository like GitHub, but you can create your own. And for example, GitHub itself allows you to create your own private registry, which in this case, registry means repository of images. So what are images? Here you have kind of an example. Okay, so basically is a template, a file that contains the instruction to create a container, and container is your application. Okay. So you see, we will do it later, but you see, this is an example of one of these templates, a very easy one. So what it says is, okay, you want to use you want to start from this application, which is an operating system. More details in a few minutes. You want to execute this command, which basically means I want to install pip. Then when I have pip, I want to install an MQTT client. And then I want to copy this source file in this directory, and then I want to execute this command. So these are the instructions. For example, here you need this source file. And so when you create this image and you download it, what your daemon will do, remember this structure, what your daemon will do is create a container. We'll see. So a container is a runnable instance of an image. It's an application, okay? Your application running. You can have as many as you want, clearly depending on the possibility of your computer. But I mean, it's very easy to run tens of containers even in very, for example, in a Raspberry. Okay, and this is what is called the life cycle of your container. Basically, you can pull a container from the repository. You can run it, execute it. While it's running, you can stop it, start it, restart it. You can control its behavior. You can build a new image. This is something we will do. And you can push it to the registry. These are the basic operations. We will also see how to tag it. We will also see how to commit. But the basic instruction, the basic sequence is you pull an image to your machine. You run it, which means from an image you create a container. You use the container, and then, so this is one side. If you want to develop something, you create your container, your image, you build it, and then you push it to the registry. We will see these steps. But remember this image, which gives you the the different steps. Just to conclude, a couple of slides. If you go back on these slides here, you know, because I was talking about deployment, you can deploy it on many different types of devices. And the scaling. So Docker allows you to scale your application from one service to tens, hundreds of services. And there are different possibilities. The easiest one is what is called Docker Swarm. Very easy to use. I will not show anything about this, but it allows you to very dynamically create new containers, deploy those containers in different hardware. When you don't need them, you can delete them. So it's very flexible and easy to use if you need it. And then there is what is called Kubernetes, which was developed by Google. And it's even a more sophisticated way to handle this type of need, which means scaling your service. Okay, so we will not see anything about this, but don't be worried, because it's if you need to use something like this, you need to scale up your service. This is a very useful resource.
So we could say that if you start doing something with Docker, the scalability might not be the problem. If you start doing the Docker way, you're starting the right way of scaling.
Yeah. If you, for example, I don't know, later we will see an example of a web service, and clearly you have typically one web service. Imagine that web service that can be using a REST interface needs to handle thousands of clients. You don't have to modify anything. It's a few instructions in Docker, in Docker Swarm, and your server will scale up dynamically to other Raspberry Pis inside the Raspberry Pis. So it can grow easily without modifying the code. So yeah. It's an interesting solution.
Yeah, and as I see it, also Docker is also a really nice way, even if you're not building server applications or something like that, but just being able to, let's say I write a Python script which does something, and I want to share with you, Pietro. So instead of me like saying that, oh, you need Python version 3.81, that's because it won't work on 3.7 because I might use some fancy function, and I use this library and that library, and it was tested on Ubuntu 20. So instead of you having to install all these kind of things by my instructions to get it to work, because it's a very, very special application, I can just hand you a Docker file and it will work.
Yes, actually you can. Actually, the last example is exactly like that. It's and actually makes it. If you want, I can go quickly to that part. It's a Python application that what is it? It's a Python application. No, it's this one. Sorry, I've enlarged so much the. So this is a Python code that connects to TTN. I think it's something that you will see next week or something like that.
Yeah.
And read some data, perform some data, modification, and prints some information. And so what you will see is you can create your own application in your machine. You create the Docker file, and you build it, you push it, and then here I can simply do Docker run the name you will give to your image, and I will execute it here. I will not have to compile anything. I don't have to take care about anything. Just test your application. And so if I found some errors, or if I like it, I can do comments. I can give you feedback in a kind of instantaneous way. Okay, so this is the theoretical part, to say in this way. So my idea here is to I think I still have half an hour, so I think maybe it's enough time to do some practical part. Just a couple of things. There are couple. If you want to, I will do it right here on the right side of the screen. If you want, you can do it on your machine. You have to install Docker. Or there is this other thing, which is, I think, very, very nice. It is offered by Docker. If you remember one of the first slides, there was the link to this web page. And what you can do here is create virtual machines. Okay, and you can, it's virtual machines that are online, and you can create up to 5 different machines, and you can work with them without having to install anything. Docker is already installed, so you can already play and do exactly what I will do here. Another interesting thing is that you can use this to test, for example, a swarm application, how your application scale with different configuration of hardware directly, again, without the need to install anything, just using this virtual windows. Okay, so anyway, just for simplicity, I will use it. I will choose option 1. Again,
and I can also just mention that the hardware, that Docker it exists for almost all hardware. You mentioned Raspberry Pi, but Macintosh, you have a Linux or
Linux,
or Windows computer.
Windows, yes,
even the new Mac M1 nowadays it works.
Yeah, I don't know. I haven't tried, but
no, but it didn't work very well in the beginning, but now it does. So it seems to be working with most applications.
I've tried and I've used it with Raspberry Pi without any problem. Raspberry Pi 3, Raspberry Pi 4, no problem at all. I use it in my Mac. I use it with Linux machines, no problem at all. So it's very cool. This option is simply if you don't want to install it and you want to try it online, it works very well. Okay, so let's start doing something. So as I said before, we have images and but actually what we are executing are containers. And containers can run in 3 different ways. They can run as a single task, so it does whatever it has to do, and then it ends, okay, which is the simplest type of application. Is an example that we'll see later. Interactively, so you can actually interact with this container. We will see it later on, and in background. So let's start with the single task. So I don't know, I hope you can see what I type. So I'm basically typing what is here. And as you know, programming, you always start with, when you learn a new programming language, you start with the hello world. In Spanish, hola mundo. In Italian, ciao mondo. So it's let's do it the same. So it's Docker container. Actually, container it's optional. So run hello world. Okay. So as you see, you can take off container, but basically what I'm saying is I want to run this image. Okay. So if you see what it says is, so it's unable to find image locally. So what it does is it pulls from the library. It says completed. It checks if the hash code is correct, and it executes it. So this is an example of single task, and this is it. So it basically prints out this message.
Yeah, and you are running an application now, so you're actually running code on your computer.
Yes,
when you execute
what I did is run that application. So here it's graphically described what I say. So I said, okay, I want to run this application. It's not in my computer. Docker cannot find an image of that for the container. So it goes to the registry, to the repository. It looks for this library, this image. It downloads it, and it executes it. And basically, now we will see. So this is the repository. Okay, this is an image, but let's go directly. So this is what is called Docker Hub, and this is this repository. And well, the repositories, these are some images that I created. And this is the kind of the official repository. So as you see, there are 8,191,000 available images. And here you have everything. So it can be analytics, you can have base images, databases, messaging services, operating system. We actually will use some operating system, programming language. You want to play Python, and if you say here Python, okay, you have many different possibilities. You have Django. You can run this and execute Python. So if we look at what we just did, we used the hello world. So the hello world is here, and basically this is the image we just executed. Okay, so this is hello world. It's considered an official images. We will see that there is these classifications, but basically says those are kind of basic images, and then there are user-created images. What you have to do is Docker pull. When you actually do run, it looks locally, and then it does the pull directly. We'll see about DAX. This is an example output. So this is kind of, if you want to see, this is kind of the README file in a GitHub repository.
Yeah.
Okay, so this is information about this image. Okay, and this structure as a GitHub README file. And how this is made create, so it refers to, regarding the source code, to a GitHub repository. And here you see there is all the code that is used to create this file. As you can see, it's a very simple code. There are different versions depending on your CPU. Okay, for example, let's go here, and this is if you have this type of CPU. And as you see, there is this Docker file, and you see that let me make it a little bigger. The Docker file is very simple, from scratch, which means don't use anything, don't use any hosting operating system. Just copy this file in this container and run that code. So as you see, there are different versions depending on your operating system. So Docker is smart enough to understand which CPU you have in this case and download the proper code. And the source file is here. It's C code, but it's very simple. It's simply a string, you see, which is this one. And when you at the main is basically when you execute this call, syswrite, put it on the standard output message, which is this string. That's it. Okay. So this is, and basically this is, remember that this is the basic example of every programming apps. Sorry, I closed the wrong. I slowed the wrong. Oops. Sorry. Where is it? Let's see if I can go back. So this is a very simple example. Okay, so hopefully this is enough to at least give an idea of the elements that constitute the whole system. So, but I mean, we'll see more examples. So what if we want to download an image? So here, for example, you want to start with an operating system, which is Ubuntu, and you actually want this specific version of your of Ubuntu. Okay, so what you do is Docker pull Ubuntu 12.04. Okay, so it thinks a little about that, and what it does is pull from library. You see that it's actually doing various sequences of downloads, and this depends on the Docker file. So since that image is composed by different layers, so it will download the different layers. Now, what you can see is that I have two images. Okay, there is this Ubuntu image, and there is this Hello World image. Okay. So now what I can do? Simply another example, if I do Docker pull Ubuntu, what it does is it downloads the latest, which means the latest version of that specific image. Okay, so now.
So, just a question there, but best practice. What's the best practice when you're creating applications with Docker? Should you always be specific, or should you be running the latest always?
It's up to you. I mean, you typically what you have to provide is like GitHub. Like consider can be kind of a branch. If you are developing a code and you have a stable version, okay, you can tag it with stable or with the number of what you consider is the last stable version.
Yeah.
Then you can create a new version, and then you can say, okay, this is version. I mean, what the tag that you put here, what is said tag, can be anything you want. Can be testing, reducing loop delay, or something like that. And so you can create a lot of versions, like you can create different branches in your GitHub repository. So you can be testing different possibilities. Yeah. Another possibility we were talking before, imagine that you designed your application and one of these services up to a certain version worked the way you want, but the designer decided to go the different way, and from a certain version up, they change the way the application works.
Yeah, and the thing is that I'm asking because I think I've learned it by doing the wrong way. That's a good thing of learning things. But last year I created a Docker Compose file for this specific course. I'm going to share that later on, a TIG stack file, which I'm very heavily inspired by what you did last year as well. Okay. But then I had the latest tag in. Actually, I didn't have a tag at all, so it automatically pulled all the latest.
Yes,
and eventually, it stopped working. So because I mean, something happened during the way. It might have been a new database version or something, but it eventually stopped working. So if you create something, at least from my perspective, and you want it to, I mean, it works now. Be very specific about which versions that you are using now. So if you know it works with the latest version now, well, exchange that latest version with what the actual version is.
Exactly. So you have to be sure. For example, before I did Docker pull Ubuntu 12.04, because I know that in that version, I had all the libraries, all the configuration that it's fine for me. Or if I want to use InfluxDB, and I know that up to version 1.8, it works the way I want. But from version to 0, so the designer decide to change the way you access the databases, and it doesn't work with the rest of services that you are, or the rest of your system. So you can say, no, I don't want the latest. I want that version because for the moment, this is how my structure, my application works. And this is another advantage of microservices. If you remember, there's one of the slides, you have microservices, and you can, I think I can show it very quickly here. Oops. Up. No, maybe it's better here. Oops, no, it doesn't allow me to open it. But so if you go here, so imagine that someone modified this service and it changed something. It changed the API, it changed the way it provides you the data, and you don't want to change the code that is here because, I mean, you are dealing already with the requirements of this other module. So you want to say, okay, you're doing nice with your new version, but let me use for the moment this other version. I solve this problem, and then I will also deal with your improvements. And this is another advantage of this approach. So as you said, you can either download the last image. So you say Docker pool Ubuntu. You want to work with Ubuntu. So which is the last version? Give it to me. Or you can work with a specific version. And then you can, using these tags, you can specify which one you want.
Yeah, and I guess that a good way to I mean, the newest version should be the most secure and updated version. So maybe when you're developing your application, you might start with the latest version, but before you ship your application, well, don't forget to change the latest tag to what you were actually using. So I think that's, at least from my own experience, that might be something that those that are listening in now might take advantage of.
Yes, so. Time. This is a distributed system. Programming and software development is a distributed system. So when you start, you can start using the latest version of the other services. But people is working in parallel with you, and so they can improve their version. So what it was the latest when you started cannot be the latest when you end up. So you have to be able to still deliver something that is stable enough, and this will give you time to take into consideration the new modification of the others and integrate those solutions in your application. But because the alternative would be not being able to deliver anything. Imagine your case. Imagine that if the developer of InfluxDB decided to delete everything before older than version 2.0. So you will have to modify everything, and in the meanwhile, you couldn't offer your application because you didn't have time to fix that specific problem. In this way, you can still deliver your solution, work on improving it, integrate the new version, and then deliver it. So there is, the end user will still be able to use your application. Maybe it's not the perfect one, but you can still work. So I think that's a useful part. Okay, so this basically with the version. Now let's as I said before, you can just execute one task. Let's run in interactive operating system. Okay, so we already downloaded Ubuntu, and then what we can do is say Docker run, and I have to add a couple of flags which are very useful. One, it means interactively, so I want to interact with this application, and -t is with my terminal, my current terminal. So it's -e, -t, and Ubuntu, and what I want to do. So I want to execute the bash. Okay. So Docker run in an interactive way using my terminal. I want to use this image, and I want to execute this command. Okay. Okay, so this is it. So this is what I just did, is basically the equivalent of installing an Ubuntu system in my machine. So I can actually in a machine, update. I can update the software. I can install. I don't know. I'm an old man, so I edit using Vim. So I can install an editor, and it's installing Vim. I can use it. I can edit, and when I do exit, that's it. Okay. So I already used that container that is based on this one, and that's it. I don't need it anymore. It's there. Where is it? Well, I can still You can still docker contain ls-l. Okay. Unfortunately, well, it's the size of the font is so. Let me see like this. So you see, I have a couple of lines. You see, this is the container ID.
Yeah.
This is the image. This is what I did, bin bash. Or this is when it says the container is exited. And this is names that are assigned to this container random. So if I, just to give you an example, if I do it again, I enter in a new container. Again, now if I do vim, it's not here. I install it in the previous image. Now this is a totally, in the other container, this is totally new container. So I don't have vim. I don't have anything of the previous. So if I do exit, and again, I list the container, you see that I have 2 containers that are based on Ubuntu. They executed the same command, and one exited about a minute ago, and one exited 2 seconds ago. If we list the images, I still have the one that I have before. I don't have one more image. Those containers were created by using this. And I can, again, run one again, exit. And if you see the containers, I have another one. So I have 3 containers based on this unique image. They had their own space, disk space. They have their own memory space. They are totally isolated. But you see the speed. I created 3 operating systems based on Ubuntu in, well, you see, if you want to count the time, but it's really, it's a couple of seconds. So it's very easy, and I have a complete operating system.
And now that, you're not defining any names now, so that you could also, it's pretty fancy names Docker is creating. So.
Yes, actually, yes, I saw one. It's kind of sounds Italian. There is this silly banzai, optimistic care, modest go. Yeah. No, we will see now how you can. It's basically a matter of saying minus name, and you can assign your own name. So
yeah. So then the question here is, where is Vim? So where did that go? So it's in the first
Vim,
container. So you install something in the first container, and
it's inside here. I cannot. I should have to exec this and go back to this and exec it. It's inside this container. So and it's isolated. It's there, and I cannot use it anymore. So it's there. So so this is important. I install it in that container. These 2 other containers do not have what I installed in this one. They are totally isolated. So they don't interfere one with the other.
But if I want to start up my container with Vim, and I don't, I have an application, and that data which is created in that container.
Yes, I think what you will do is, if I do docker exec, let's see if it works. Yes, docker. Let's see. No, okay. But no, the way I came up to here, now I cannot run it again. Okay. So I have to work in a different way. I have to use it detached. So we will see how to do it later. So now the problem is that now it's exited, and it's more complicated to get access to this container. Okay. Yeah. So so these are basically the command that I already showed you. Image ls means it allows you to see the image that we downloaded. Container. So this is a very simple difference. If you use Docker container ls, you see, by itself, ls just show the executing the container that are executing. If I have to do -a to see also those that are exited, that are terminated. One interesting thing, you typically, if you want to design an application for IoT, which is supposed to run in resources limited devices, you don't use Ubuntu or operating system that are so big. There is a nice Linux distribution, which is Alpine. I don't know if you heard about it. And this is a very, sorry. This is a very interesting version of Linux. And the advantage is that if you user Docker image pool Alpine, okay, so Docker image ls. So we have it, you see, and you see the difference in size. Okay, so Ubuntu is 72 megabytes, and Alpine is 5 megabytes. So if you just need a very, and this is important for IoT application where you need to design lean application, this is a big advantage. So so we can. I always try to click to copy and paste, but it's not. So if you want to just, for example, Docker container run Alpine, for example, echo hola mundo, something like that. So this is kind of very static application. Just I ran this operating system and executed this instruction. So this is the different instances. As I told you before, Docker container ls -r. See, there is this last execution of Alpine that I did, and you see I'm accumulating containers. But again, if you see the image, are still these images that we downloaded before. Another interesting thing is this one. So you can run, which is kind of, we are going back to the question that I said before. What if we want to go use a container and not using? So this is what is called detached. And this is very useful. So you can do Docker run -d for detach, interactive, connected to my terminal. This is the instruction I told you before. --name allows you to assign a name, just Alpine1, for example, and Alpine. And then I want to use a shell, which is hash. Okay. So, oops. Why is not working? Oops, I don't know why it's not working.
Can't see any.
True. No. Sorry, I'm. So Docker. Oh, no. Sure. Sorry, I was thinking for a different container ls -r. So you see, now I created two, but doesn't matter. So now you see I have a couple of containers, Alpine 2 and Alpine 1. Now they have the names that I gave to them, not these fancy names. And you see, differently from this other, they are up, they are executed. So now we go it. What if I want to let's say execute, enter in those operating systems? What I have to do is Docker and attach, and for example, Alpine 1. Okay. So now I'm inside that Alpine. So I can do an ls -r. Okay, I think they already have. So I already have PI, and I can edit the file. Okay. Now I'm inside. What I can do, I can exit, and that will exit the container. Or I can use the sequence, Control P, Control Q, Control P, Q. And what I did is simply, let's say, get out from the container. If I do a list, you see that the container is still up. And what I can do is I can go back once again and redo whatever I want. So if I, for example, install something in this container, I can enter again and I can use it again. Okay, and that's it. Okay, so this is the very basic part of containers. Okay, I don't know if there are questions or doubts. I don't know if we have more time. I don't know exactly this schedule.
Yeah, we have done an hour, and I'm so happy that, I mean, it's always, actually, I think that's a good sign when everything works too well, and you actually, it becomes almost too planned. So there was some discussion. I've asked as good as I can, so I'll lift those questions, and maybe you can correct me. But there was some, how do we save things if we're running a container? And my explanation, and please correct me if I'm wrong, is that a container should be, if you're creating something, it should be sort of created from scratch when you need it. And if you want to have persistent information, it should be in a volume. It could be a Docker volume, or it could be on the local disk, or it could be that it's interacting with the database somewhere else on the internet.
Yeah, exactly. Yeah, I mean, yes, there are a lot of details. Yes, as you're saying correctly. You have two ways. You can use Docker volumes, which is a way for Docker to handle permanent storage, or you can associate the internal file system of the container to the file system of your machine. So whatever goes to a particular part of the file system of the container goes to your physical file system of your machine. So you will not lose anything. And exactly, typically when you're using databases, you either use volumes, which is a standard option in Docker, or you associate the location in the container where the database application you're using stores the data. You associate it with your data file system.
And I can just show, this is now me showing my screen. So I just took the screen from you now, Pietro. Okay. So just to make try to make a practical example, and also get the opportunity to show the students in the course what they should be working on when they're using Docker. You explained a little bit about Balina. That's a great thing, but I don't think many students are working with Raspberry Pis. They might be using them more as the server rather than but the TIG stack, and this is Telegraph Influx Grafana. And this is created. So it's really, I'm giving the credit to the man which is in the meeting. It's Pietro that originally did a Docker Compose file for this. And I used it with some modifications last year, and now it's updated, so it should work. So I'll just show. And the thing is, when you did this one Docker file for each line, you can combine all these things in a Docker Compose file, which is sort of running several Docker containers. You create a recipe, and you do a lot of Docker stuff in one file. Is that correct?
Yeah, no, perfectly correct. Yeah. Docker Compose is my idea. The Docker Compose allows exactly what you said. It allows you to, the term that is typically used is orchestrate or coordinate the execution of different containers. Yeah. And the example that you're showing, it does exactly that.
Yeah. So in this case, and you all can actually find this. It's in our repository. I'll put it directly in the Discord chat, so you can directly go and see this. It says 2 hours ago. It has been there longer than that, but I actually changed I moved the repository, so it's in its own. But this is a TIG stack, and why Docker is so powerful, I will show you now. Because without any knowledge of Docker, you have learned a lot on what Docker is, but without even knowing that, you might go and install Docker on your machine, and that is super simple. You'll find it very fast. And then you can go to this repository. You can download all the files. If you don't have Git installed on your computer, it's totally fine to download a zip file and extract that on your computer. Otherwise, just write git clone and the name of the repository, and voila, you have the GitHub repository. And then you can see here that I'll make it a little bit bigger, that we now have a couple of files, which are the same as we do have in the repository behind me. And if we look here now at the Docker compose file, let's see if I can get that working. Yeah, you can see terribly slow, sluggish Visual Studio Code here. I was going to show. I'm not sure why this. Yeah, I'll try again. Okay. I'll do it. You see, I'm not as old as you, so let's do Nano. But maybe not as visual as Visual Studio Code. I'm not sure why this didn't work. But anyway, we can see here in the Docker compose file. And just to be very show what you can see here is that these are a couple of services. And instead, I could have installed all these services one by one. But now I'm not doing that. I've put it in a Docker compose file. So you can see the configuration here. We have an influx database. That's the I in the TIG stack. We have the Grafana, which is a visualization tool, which is the G in the TIG stack. And we also have Telegraph, which is the T in the TIG stack. That might be a bit over obvious. But you can see that there are images here. So image Telegraph, and there is 1.19.0, and Grafana is a specific version. You can see ports, and there is some environment variables. Often you configure these Docker files with environment variables. That is maybe one thing that is very important when you're running these things, is that you'll find that a lot of the configuration you're doing when you're using a Docker, like a ready-to-use Docker file, can be configured just by this environment variables. So we have a King Arthur password. That's the password for the Grafana. And there is a couple of influx IoT, LNU, and MicroPython. So you can change them to whatever you want. The important thing here is that you can see the volumes here, which is the persistent part. Obviously, when you're creating a Docker and you want to have a database, it makes no sense if everything disappears when you close the Docker file. If you restart your computer or the server goes down, everything disappears. That might not be a very good thing. So in this case, it's actually creating a TIG data volume. So Docker is creating a volume which is not flushed, and you can use it and actually go into that volume and back up it and such. So both the Grafana and the Influx are using the same volume. The only thing that I've used for like the disk access part is the Telegraph configuration file. You can see here that it's dot and slash. That means that we are searching in the folder where we are. And well, that's the Telegraph configuration file. Instead of inputting in environment variables, I'm using that as a file. And this is the new Docker. The old Docker you had, I think, it like this. I guess both work still. But if I write Docker compose up, you can all do this now. If you have Docker installed, Docker compose comes pre-installed for everything. Now it downloads all the images. It runs and starts all the services. And voila, I have my TIG stack up and running. So if I go to localhost and port 3000, I'm running Grafana. So I'm running my full IoT visualization hub with the database and everything. So you need to configure the influx. I've already done that actually, but you need to configure the influx database. Don't forget that. There are some instructions in the README file and the user database and password. But yeah. And the Telegraph configuration file. I won't spend too much time here, but I'm just showing what it's super easy. The same thing if you want to run Node-RED. Actually, it's on Node-RED homepage, get started, run it with Docker. And this is just one example. What you can do right away is I'll close this one. And I just press Control-C, and then I'm closing all the services. If I would have put is it the D flag, the demonize flag, like this, then it would run in the background. But now, if I want to run Node-RED, I'm just copying and paste. You can see here that it shows the local host. And we'll go here, and voila. I have Node-RED up and running on my local computer, which is a super nice tool to have when you're working with IoT. So that was like, I just wanted to give like, okay, 2 things which you can do right away now when you know Docker. So
no, yes, I mean that's one of the actually the way I use it. Compose applications by combining different services, or run code without installing, and that's the perfect way. I don't know if you have time, but I leave this to those that may be interested. This part is how you can create your own image, okay? And actually, you will see that there are basically 3 examples, just in a couple of minutes. One, you can create your own image starting from another container. So, for example, you see here, let me just, to go fast. Where is the menu? Okay, so you can run an Ubuntu, and you can install inside that Ubuntu, for example, an application. This is called Figlet. It's a very simple application. Once you have your application, you created your container. You do a commit, and what you do is create a new image. Okay, and so basically, it's like, imagine with the virtual operating. If you're installing a virtual operating system, you install in that operating system all the software that you need, and then you deliver that image that you created. So here the same, but in this case, what you create, it's a new image starting from a container that you just created. You can assign your tags, and from that moment on, what you have is your application. Then there is another application, and this is placed with Flask. Flask is a kind of web server, which is used, since it's very tiny, it's used to create REST interfaces in IoT applications. And here you have the application, which is very simple application. Then when you send a GET, it delivers you a random image of a pizza, kind of application. You have all the code. And the Docker file, it's...
So Pietro, that was your, like, what you did in Italy. So
yeah, basically what I did. So you see the Docker file, you say from Alpine, you install the software that you need, you install this Flask, you install these web pages, these Python code and these web pages, and you run it. And this can be executed anywhere. And the last one is, it can be executed. Important things. For the moment, what you create is the image is local, okay? But as I said many times, okay, you want to share these images, you want others to test your application to see if it works. And this is very easy. So what you have to do is basically with these 2 instructions, Docker login, you connect to the app service, to the repository. You will be asked for your username and your password when you create your user in that repository. And Docker push your username in the platform and the name you want to associate, and that's it. Once you do this, once you did this push, anyone can do a Docker run, your username, the name of your image, and it's downloaded into your machine. Okay. And so that's why. And here the last example is this one with code to connect to a TTN server. Okay, this is the Python code. I think it will be explained to you in a week or two. In this case, it provides this part, and you see the Docker the Docker file is this one, very simple. Again, using Alpine, install what you need. In this case, for example, you need this Pajo library, which is the one you need to program with MQTT in Python. You copy your source file, and that's it. So you build it, and you can run it here, or you can upload it and run it anywhere. Okay, and you can do it in minutes or less. And this is something beside what Fredrik showed you before on running and executing in an orchestrated way many different applications. The possibility to create your own code and simply give it to someone else that he can execute it in a few seconds and gives you feedback about whether it's working or not. It's really a powerful tool.
Yeah, and also that you can create something on your laptop, on your home computer, and get it to work, and then you can deploy it on a Google server somewhere else.
Yeah.
And run it times 1,000. So that's really powerful, as I see it.
Yeah,
So
I mean, in 1 hour it's difficult to show everything about Docker, but believe me, just it's very easy. There is, I mean, for probably the beginning there is a kind of confusion between images and containers, but once you get there, then the other problem is actually what happens to my data when my container is gone. So no, it can be there. And then the other thing is create your own images, distributed them, combine them with others, and so you will see that it's very simple and very useful. And the next step, scale it. So have your application to run not just a single process, but as many processes as you want. So a lot of possibility. Hopefully in this few minutes, I gave you a general idea of how it can be used.
I think so. There are not many questions. I think we covered all the questions and comments during the way. And I guess that people are playing full time now with Docker. So I see that the views, like we have 24 that are watching live now, but it has been rising all the time, which is a good sign, I guess. Not dropping. So
how many are there now? Just
24. We have 24 that are watching. So, okay. But I guess that most people are watching not when it's live. Generally, I think that's been so far. Okay, but in that case, I think we'll wrap it up. So the takeaway from this is that you should really start playing around a little bit with Docker, learn how to do it, but don't be intimidated and afraid of that you don't understand everything. It's not a requirement of the course that you know how to operate Docker. See this as a tool to use for actually making really great things working on your computer with very, very little effort. Because in reality, you can use this as a way of I want to install Node-RED. Okay, I install Docker. That's all that you know.
Yeah.
And you run one command, copy-paste, and you have Node-RED on your computer. So that's really also a way to use it. And then you can take a step at a time. So I'm just saying that don't feel that, okay, this seems too much. Start with just using it. and then I'm sure you will find the usefulness afterwards. So
yeah, just for curiosity, go to Docker Hub, create your account, and just take a look here. Do it, explore, and look for software that you always wanted to test, and just do it. And so
I know there are several. I think I've seen some that like IoT dashboards. So you might be a good exercise to Google around and see if you find something with IoT in Docker. Someone might have created something that is great.
You can do. No, there is Balina. ThingsBoard, you can have even execute. I don't know if you've played with ThingsBoard. There is already there.
Yeah.
Well, there are many of them available. There's Python. There are Debian Python. So if you like, there are 7,600 with just looking for IoT. So.
And if you combine IoT and dashboard, you still get 11,000 results.
So again,
and many things might not be relevant, or they might not work as intended, or they might be hard to understand. But it gives you people, could be anyone, that have created their own fancy system at home, and they publish it, and you can leverage on that and look, and okay, this looks really nice.
Actually, just be careful. One thing that is in the slide, when you select categories, there are, because you have to. It's a safe environment. It's a safe tool, but you have to be careful that there are official images. So, for example, this is the Python official image. Then there are verified publishers. So, and then there are users. So when you use official images, you know that they have a certain quality. When you use generic user images, the quality can be whatever. But maybe they are useful to you. Maybe they can give you some idea on how to create your own container.
Yeah. And ThingsBoard, that's a Spanish company, isn't it? Or is it Finger.io? Or I always
No, ThingsBoard. Oops, sorry.
Because that is something that it's an IoT platform.
Yeah,
I've tried it out, and I must say that it was well, I didn't digest everything that you could do in it, but that's actually one thing that is very easy to install with Docker. So it might very well be worth exploring.
Yes, it's. I'm not an expert in ThingsBoard. I used it. I installed it in Raspberry Pi just to test it. I kind of use it more. I kind of prefer other platform. I'm more in the TIG approach, which is more flexible. Here, it seems that it's simply paid version, but you have this community edition, but you have to install it in your own hardware.
Yeah.
The professional edition, you have to pay for it. But again, there are other alternatives, and I think the TIG alternative, it's more interesting for me.
Yeah, you can do so many things, and we have covered these low-code IoT platforms. There are several. We had DataCake like a couple of weeks ago, and there are so many, so it's hard to cover them all. But now we're in an area where, well, you're sort of creating your own solution from, I wouldn't say from scratch. You're still depending on like your database and Grafana, but you're more combining whatever you need to create your own solution.
Yeah. Actually, Grafana gives a lot of possibilities, and the fact that you can have your own data, you can take different sources, I think that makes it more attractive. And moreover, that you do not depend on a unique tool. You don't depend on ThingsBoard. You depend on a database. You depend on a data collector, Telegraph, and you depend on a visualization tool. And that's the other idea of microservices. If you want to use a new database service, a new database software, you can use it, and you can plug it in and integrate it. If you want to use Telegraph, you can use it. If you don't want it, I did the code in Python that does the same work, and maybe it's not as efficient as Telegraph, but it works. So you take off Telegraph, you put your Python code that does the same work. So
yeah. Sorry, it was me that I clicked on the wrong button, so that's why.
Yeah, no. It was nice when you were below, because I looked down because my screen is there. So I'm sorry.
Okay. But anyway, I think that we are have used our time now. So I think that we'll say goodbye to everyone in the class, and I'll end it here.